Okay, in this video we're still looking at patterns. So in this video we're looking at geometric patterns, which are also called geometric sequences. So in our previous videos we talked about an arithmetic sequence, which we referred to it as saying if a sequence is arithmetic, what do we know about it? We know that there's a common difference. This is just a quick recap. We know that there is a common difference. Now, when we're looking at a geometric sequence, we're no longer talking about a common difference, but we're talking about a common ratio, which is referred to as A. So for a geometric sequence, we no longer talk about common difference, we talk about a constant ratio. And this constant ratio has to be between successive terms. So what we really mean by saying terms are successive, so we talk about term number 1. After term number 1, the next term is term number 2, and the next term is term number 3, and so on. So what we talk about when we talk about this ratio, we simply say that we refer to it as R. So we say R, which is the ratio, must be term, let's talk about n. So term number n plus 1, n is just the position, it can be any number, any position. So we talk about R is equal to Tn plus 1, and this R must be divided by Tn, which means we have the bigger number as the denominator and the smaller number as the denominator. And an example of this, we can say R is equal to term number 2 divided by term number 1, and is the same as term number 3 divided by term number 2, and so on. So this is what we refer to when you talk about the common difference. I'm just going to give an example of a sequence. Let me change the color. So we have this sequence over here. Let me choose this one. We have this sequence. This sequence is 2, 1, a half, and a quarter, and 1/4. So these are our terms. This is T1, this is T2, this is T3, and then this is T4. So for us to prove that such a sequence is arithmetic, what we would have to do is to simply calculate the R, and if the R is the same, that means the sequence is geometric. So our R will simply be equal to term number 2, which is 1/2. So R is equal to 1. Let's see if it's the same when we move to the next one. So the next one will be R is equal to this one, 1/2 divided by 1, which will also give 1/2. And the next one will be 1/4, this one, divided by 1/2, which will also give a half. And therefore from there we're able to conclude that we have a geometric sequence. So this is the process that you follow to prove that a sequence is geometric. The next thing that we're going to talk about is how do you find the next term? Remember, in an arithmetic sequence, if you have term number 3 and you want to find out term number 4, all you do is that you add the common difference. So what about in a geometric sequence? So we can still look at let's look at the same, or at the very same example, this one. I'm just gonna write it again. Over here we have 2, 1, 1/2, and 1/4, and 1/4. So how do we move? The question is, how do we move from 2 to 1, and then from 1 to 1/2 to 1/2 here, and then from 1/2 to 1/4? How do we move between all these terms? Okay, remember we talked about common ratio. We said the formula is simply R is equal to, for example, let's say T3 over T2. And in this example, we found out that the R is 1/2. So we have a half is equal to T3 over T2. So in this example, we already know term number 2, but we want to find out term number 3, and we're just describing how we go about it. So we want to find out term number 3. we already have term number 2. Term number 2 is 1, and then all of that is equal to 1 over 2. So from this equation to solve for t3, we're just going to multiply. It's actually just solved. So t3 is the same as a half, and this is what you can see over here. So the basic deduction from this is that if you have term number n and you want to find out term number n plus 1, what you do is that you simply take term number n and multiply it by the common ratio, which is r. So for example, if we wanted to find out term number 2, what we would just do is to just say this one, 2 multiplied by the common ratio, which is 1 over 2, and this would give 1, and we move along the same way. So let's say this is the sequence. Let's extend it together. So if we wanted to find term number 5, what would we do? We would say 1 over 4 multiplied by 1 over 2, which would give 1 over 8. And then from there, 1 over 8 multiplied by 1 over 2, which would give 1 over 16, and so on. So this is how you expand a geometric sequence when you already know the common difference. Okay, so this is just another general formula that you can use, but we now want to derive a general formula using the simple Tn. So you agree with me that in a geometric sequence, let's say if you're only given the first term, which is a, it still holds that the first term is a. So if you're only given a and you're also told the common ratio, that means you can find out all the terms in a geometric sequence. So for example, let's say this is going to be a multiplied by, how do we, from term number 1, which is a, how do we find out term number 2? We simply multiply it by the r to the power of what? So for this, we're just going to say it's r to the power of, because we're saying we only multiply it by r, so it's r to the power of 1, and that 1 is basically just term, because this one over here is term number 2, so it's simply 2 minus 1. So if we had term number n, we would say just n minus 1, and this would be your general formula for a geometric sequence. So we have a r to the power of n minus 1. It's an important formula. It's what you will be using throughout whenever they talk about finding the general term of an arithmetic sequence. This is what you look at. Tn is equal to ar n plus 1, and another important thing that we talked about is Tn plus 1. If you want to find out the next term, you simply say Tn multiplied by r. Okay, and then how do we find out the r? We find it out like this over here: Tn plus 1 divided by Tn. So in essence, all that we've talked about can be summarized. We can say because we have the Tn, it means that every term of the sequence, every term can be written in the form of a and r. So for example, if we wanted to find out, of course, T1 is just going to be equal to a, because that will be 1 minus 1, and anything to the power of 0 is that thing. So T2 would be just a to the power of r, because this will be 2 minus 1. And then T3 will be a r to the power of 2. So any term of an arithmetic sequence can actually be written in the form of a and r. And that was the basic introduction that I had for you when we're looking at geometric sequence. Thank you for watching.